Good evening, all of you. Today we are going to see a class 10 physics problem based on circuit theory that involves a single bulb and two bulbs. Let me read out the question. Kaveri conducted an experiment to study the energy efficiency of different bulbs. She connected a bulb A having a resistance of 100 ohms to a 240 volts power supply in a laboratory. Question 1. How much energy will be consumed by the bulb if it is kept on for 4 hours each day for a week? So 7 days. 1 week, 7 days. Express your answer in kilojoules. This is the first part of the question. Second part, Kaveri connects another similar bulb B in series with bulb A. So this is bulb A, this is bulb B. Identical bulbs. Will there be any change in the brightness with which bulb A glows now? Explain mathematically. So this is the question. So the thing is, Kaveri connects a bulb of the filament resistance being 100 ohms, and this is switched on for 4 hours per day. The switch is closed for 4 hours per day. So totally we have to calculate for 1 week, that is 7 days. And also we know that 1 watt second, watt is power, unit of power, multiplied by second will give you 1 joule. So we have to express the answer in kilojoules. So when the circuit is closed, what is the current flowing in the circuit? I is equal to V by R. That is, V is 240 volts, R is 100. I is equal to V by R. So now this will give you 2.4 amps. Or I can write it as 24 by 10 amps itself. Now, so this is the current flowing in the circuit. Now we have to calculate the power. Power is equal to V into I. The voltage across the load, that is the bulb, is 240, and the current flowing in the circuit or through the bulb is 2.4 amps. So voltage is 240 multiplied by current. Current I can write 2.4. Equivalently I can write 24 by 10. So these 0 will get cancelled. So now 24 into 24 multiplied by 24. 4 4s are 16, balance 1, 4 2s are 8, 9, 4 2s are 8, 2 2s are 4, 6. So 576 watt. That is, when you multiply 24 into 24, you will be getting 576 watt. So this is for power of the bulb. So the next step will be, we have to calculate the energy. So for this case, energy is equal to power multiplied by time. Now we know power is 576 watt multiplied by time. Time 4 hours and 7 days. So 7 days, 4 hours. So 4 into 1 hour. 1 hour means 60 minutes. then 1 minute 60 seconds. So 1 hour can be written as 60 into 1 minute. 1 minute is 60 seconds. So 60 into 60. Okay. So I have converted the entire thing into second. This value into second. So if you multiply, you will be getting the answer as 576 into 7 into 4 into 60 into 60. So this will give you 580 60 800 watt second. 580 60 800 watt second. So now this watt second can be replaced by 1 watt second is equal to 1 joule. So watt second can be replaced by 1 joule. So this can be written as 580 60 800 joules J. So the question is, we have to express the answer in kilojoules. So energy is equal to 580 60 .800 kilojoules. So let me check out the answer. 580 60 .800 kilojoules. So first part of the answer is correct. Okay. Now what we have to do is the second part of the question. Okay. Now what Kaveri does is, she is connecting two bulbs in series. The circuit is switched on. So the question is, Kaveri connects another similar bulb B in series with bulb A and connects the combination to a 240 volt supply. Will there be any change in the brightness with which bulb glows? A glows now. Explain mathematically. That means we are not interested in calculating the energy, we are interested in calculating the power. So for this what we have to do is, so when the circuit is closed, current will flow. Both the resistance are in series. So now the current flowing in the circuit I is equal to V by R. In this case R is R total. So V is 240 divided by 100 plus 100 is 200. Okay. So 12 by 10. So this is equal to 1.2 ampere. Current will flowing in the circuit. Now the total power, individual power also you can calculate, I square R. I want the power for this, which is I square R. I is 1.2 square multiplied by 100. That is 1.2 into 1.2 into 100. Okay. 12 square is 144. So 144, you have to place two decimals. So 1.444 into 100. That is, when you multiply, you will get 144 watt. So this bulb, the power is 144 watt. Now this bulb is glowing with a power rating of 144 watt. This also same current will flow in the series circuit. So there is, the power will be same because the resistance is also same. So this will also give you 144 watt. So total power, if you want to see, you add both these things, it will be 288 watt total power. Now you just compare, assume this is bulb A and this is bulb B. In the second case, the power is 144 watt only. Whereas in the first case, with only single bulb, you are getting 576 watt. Therefore, in the case 1, this bulb A will glow brightly, whereas in case 2, since these two bulbs are connected in series, the overall power of the bulb A is 144 watt, bulb B is 144 watt. Put together, it is only 288 watt. That is another observation. So, the brightness of the bulb A decreased because of this series connection. Hope you have understood this problem. Thanks for watching this video. Nandri.